Hey everybody, Steph here. So somebody asked if I could go over some load balancing ideas with regards to deploying your app on the cloud. Now, I'm no expert in cloud-based load balancing, but I'll tell you what I've seen out there and what we've considered and what we're going to be doing with Studio Web or what we've done. So number one, um, you can look at load balancing on a server level, and you can also look at it how it can be implemented within your app itself in terms of how you distribute the load. So when I'm talking about load, I'm talking about traffic load, how many people, how many users hitting your app. And in this context, I'm talking about, of course, web-based applications, whether it be PHP, Python, Java, C Sharp, Ruby-based, whatever. And the different load balancing strategies are dependent on your particular circumstances. So, for instance, you may have an app that's very database intensive, meaning all the CPU load will be actually executed, for lack of better terms, will be executed on the database level rather on your app model or your object level. So depending on where the load is, you might, well, you're going to change your load balancing strategy. So the simple strategy, we'll call it the round robin strategy in terms of, again, web apps. So you have one web server that sits there and waits for requests to come in. Now, I'm discussing things here with the assumption that you've written some code and you know some of the basics, request, response, server, client, database, that kind of thing. I'm not going to get into that here. So you got one web server that's sort of sitting there and it's taking in requests. And this is a very lightweight server. It doesn't take much memory, it doesn't take much CPU because all it does is it's just routing request. And it's routing request to different installs of your main app. So you have your router up here, and then you got your main app. So let's say you have your main router and you have three instances of your app. One, two, three. They run independent of each other. They're each, excuse me, on their own virtual machine. So they have their own CPU, they have their own RAM. So what this is kind of a dumb round robin distribution style on the request. So as a request comes into your load balancer at the top of a pyramid, you got this top one at the peak of the pyramid, and you got three apps on the base. This thing takes the request and routes it to server number one. Then it routes it to virtual server number two. Then it routes it to virtual server number three, and it does it again. Boom, 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 boom. This is kind of a dum-dum system. So I call this a dum-dum system because the router at the peak of the pyramid does not check to see the load on each instance of the app. So this might get overloaded. Instance number one, and in instance number two may not have too many people on it, even though it's round robining. Maybe a lot of the people, the users are on instance number two, maybe they locked off, whereas a lot of people just keep on sticking on instance number one. Now, this is kind of a very basic way of load balancing. Now, one thing I should mention about this style of load balancing, where you have the router and the three instances, they would typically share one database. So you think of it's like a top. So you have the load balancer at the bottom end, you have the database at the bottom, at the load balancer at the top, database at the bottom. In between, you got your instances of the app. In that situation, they're all sharing the same database. This is just one style. You would lose this style of load balancing if the processing was really heavy duty on the app level, right? Because you're sharing one database. So this one database, of course, would be on another virtual server with its own RAM, its own memory, its own CPU, and so forth. RAM, CPU, RAM and memory, same thing. So its own memory, its own CPU, and yeah, so the three instance apps would share that. That's just one strategy. Maybe you have another situation where the heavy load is going to be on the database. So in that situation, you may want to distribute your database. Now that's a whole different way of approaching that. Now, I know that AWS has this ingenious way, which I've just read about, talked about a bit, where you have to design your database from the get-go in a certain way, but then they will be able to take care of the load balancing of your database access. They'll take care of replication and all kinds of other things like that It's very, very sophisticated, very powerful, and it's super cool from a nerd's point of view. So that's another way. A dumb way of dealing with database load is to maybe have different tables in your database held on different servers. So you might have your user table on one database and then have a sales table on another database, and so that, you know, the processing of all this kind of stuff could be done on separate virtual machines. Another thing you could do is maybe have long-term records that you hold in your database periodically stored on a third database or a fourth database separate from the active database. So when you're generating heavy-duty reports that take a lot of number crunching, you number crunch on another server, so you don't affect the performance of your main active servers. So you may have a reporting database that just deals with the reporting end of things. See, I'm just a couple of strategies I mentioned off the top of my head. Now, what we're doing something I just call it the dum-dum strategy. And I'm able to do that because with our app, we can segment the app by region, even by client if they're big enough. So I can have a version of I have an install rather of my app for just Texas, another install of my app for just California, another install for whatever. You get the idea. And what we're doing is we're having, for smaller areas, we'll have just an app database sitting in the same virtual space or same virtual server. And so if we have like New York State, they have their own, right? And California, though, they're bigger. We may divide that into different sections. So I have California South, Central, North, you know, each one with their own install. The install would include both the database and the app itself. No load balancing requirement. Now, if you want to step that up, you can set it up within a region where you have load balancing built in, like the first strategy. 1, 2, 3, database shared by the 3 instances with a load balancer at the peak. I hope this makes sense. You might use that. So California would say it's a big state, you might do that there. So it depends. How you load balance is a bit of a tricky issue, but let me tell you, because as I said in the cloud server vlog, it's so much easier than it used to be. It's unbelievable. All right, somebody just pinged me on my phone. So that's the end of this vlog.